Hello and welcome to the Moving Right and Moving Left pre-activity. This is following our toy car lab where we figured out the relationship between the distance and the time for the toy car. And we're going to use the toy car again, except this time we're going to put it on a track. And instead of laying down blocks for intervals of time with a stopwatch, we're going to use a little more high-tech device. This high-tech device is called a motion detector. It's a little black box that is sitting on the end of every track in the back of the room. The motion detector is something that detects motion. It allows us to make some very quick graphs in real time and does some pretty cool things for us. We're going to use it quite a bit this year. What the motion detector essentially does is it makes clicks, and every click is a sound. And that sound goes out, bounces off the car, and goes back. So again, sound goes out, bounces off the car, comes back, right? Like an echo. And the motion detector can sense that sound. So it knows when it puts the sound out, and then it times how long it takes to go out and come back. Once it has that time, it then puts that time into the equation, the same one that we found for constant speed, that the distance that sound moved is equal to the speed the sound moved at times the time. And this speed of sound is just a number that it automatically uses. It assumes a normal, typical pressure and temperature room. And then it measures the distance that sound moved. Now, since the sound came out and went back, the car is actually half that distance away from the motion detector. So the motion detector immediately then cuts that in half. Now, it can do this many, many times a second. I believe in this activity, I've got it set at something called 30 hertz, and that means 30 times per second. It's making a click and calculating exactly where the car is. So this is taking way more data than we ever could have with the toy car lab. It then immediately takes that data and it realizes here that it's not measuring the distance the car has moved. Each time it kicks a sound out and it comes back, it's calculating where the car is. That's a little subtle thing. So not how far it moved, but where it actually is. This is what we call position. So we're going to define a new term here. Position is where an object is located at a particular instant of time. And you can define something's position in 1, 2, or 3 dimensions. We're mainly going to do 1 and 2 dimensions in this class. We add the third on in AP. And that's why there's 3 symbols. X, Y, or Z stands for position. X is if you're talking about horizontal position. So our car's position here, since it's moving horizontally, would be defined with a symbol X. If we're talking about something falling through the air vertically, then we have Y positions. And if we're talking about going in and out of the screen, then we're talking Z positions. And we're not going to use Z here, but we'll use X and Y. So a couple different symbols for position. Like I said, the motion detector figures out the position of the toy car like 30 times every second. And then it immediately makes a graph. So here's a program that you're going to use. It's a program called Data Studio. We're going to use Data Studio all the time in order to run the equipment and do some basic graphing. We're going to use Logger Pro mainly when we type data in to do graphing. Data Studio actually runs our equipment. Now normally when you turn on Data Studio, this little start button should be lit. All right, right now it's not because we're not connected to anything. Usually to make this lit, and so that you can click it and actually start collecting data, you have to turn the interface on. The interface is the black box next to the computer, and if it's off, it needs to be turned on. And then you go to Experiment, Connect to Interface. Sometimes, however, it doesn't read the interface because it's USB, if you've ever had that issue with other USB-connected devices. And then again, you have to turn it off, turn it back on, go to Experiment, Connect to Interface. That's going to fix 99% of the problems. If you have any other problem, call me over and I'll help you with it. So, when you hit Start and you let your toy car go, it's going to collect data. And in real time, it's basically going to graph the position of the toy car, where the toy car is, as a function of time. And so in this activity, we're going to look at what this graph tells us. We're going to kind of match it to some different motions and see exactly what this graph means and what do the parts of this graph mean. What does the slope of a position time graph tell you? What does the y-intercept on a position time graph tell you? Things like that is what we're going to do in this activity. Now, a couple of things about the motion detector. The motion detector thinks of itself as 0 position. So any position it puts on the graph, right, is measured from the motion detector. In order to get the smoothest graph, your motion detector, this thing can turn, this part right here can turn, and usually it needs to be kind of like it is here, a little about a half a click back. You'll see little clicks on the side, and about half a click back. If you turn it too far up, the sound waves will go over the top and won't come back. If you turn it too far down, they'll bounce off the track and go over and won't come back. So in order to get a nice smooth graph, you have to rotate it back a little bit. Now, if your graph's not smooth and you can't rotate it a little bit, call me over and I'll help you with it. And the other thing about a motion detector is that its brain kind of works like ours. You know that in a small room you can't hear an echo. The reason you can't hear an echo is because if the sound bounces off the wall and comes back to your ear in less than about 1/10 of a second, your brain can't distinguish the echo from the original sound. And so it only hears one sound. So you have to be in a big enough place where the time it takes for the sound to leave you, hit something, and bounce back is more than 1/10 of a second. If it's more than 1/10 of a second, you hear two distinct sounds. Right? You hear the echo. Well, the motion detector is the same way. If the object is too close to the motion detector, the sound comes back too quickly for the motion detector to hear it as a separate sound, and then it doesn't record anything. It doesn't know something's there. So there's a 15-centimeter dead zone in front of the motion detector. And by the way, there's a centimeter scale right on the track. So you'll be able to see, you'll have to start your cart at least 15, 20 centimeters away so that the motion detector will see it. So follow the lab sheet and do exactly what it says and have fun and learn something about position and time graphs.